Okay. After the main presentations, we will have some time for questions, and for those of you who will stay, they'll have this opportunity to ask questions. The next speaker is Timothy Kramer. He is an astronaut, and you know, we normal human beings usually feel inferior towards astronauts. That's why I'll call you Colonel Kramer, because I'm a general, so I feel more confident. Timothy earned his BS in chemistry and then a Master's of Physics from MIT in '92. And he has a lot of experience in NASA. It's sufficient to mention only that around a year ago, a little bit more than a year ago, he was launched aboard the Soyuz capsule to the International Space Station, and overall stayed 160 days in space. Timothy, please.
First and foremost, it's a delight and a true excitement for me to be here to share some of the fun stuff with you. Laurie was mentioning all of the, we can go ahead and pause that once it starts up. The science that we're shooting for the next coming year and some of the outlooks for the years coming ahead. And with your help and with the help of many of our partners, we hope to be able to get to the point where folks all around the world are excited and are talking about what we're doing in space and space exploration around the dinner table each night. And part of that happens to be the human exploration that we're performing now on a daily basis. And for the past 10 years, we've had humans in space. And from my perspective, the job that I have is like one of the best in the galaxy. And as a result of that, some of the science that we're doing on board, we're talking the whole gamut of what you can imagine right now. We're doing material sciences, fluid combustions, metabolics. We're doing material research. And this is happening on a daily basis. When we get up in the morning on the space station, it is our goal to maximize all the time we have in order to be doing the utilization and the experiments that so many people have been putting years behind in order to get on the space station. Space station is unique. It's a floating laboratory in this world we call space around Earth, and it allows us to remove the gravity component from a lot of equations. Off the top of my head, let me simply just bait you with a couple of thoughts. On Earth, the flame looks like a teardrop in a candle because the air comes in from behind, underneath and convectively rises as it gets warm. But rises mean that air knows where up and down is, and we don't have up and down on orbit. So the flames form a perfect sphere when they burn on orbit, and we can now do combustion studies on a very pure level. Cancer cells that you're growing and trying to understand the processes by which cancer cells form, and therefore to destroy the cancer cells, can crush themselves under their own weight in gravity. But if you grow cancer cells on orbit, you get to see the perfect cancer cell growing. And so now you begin to understand how to interrupt that process. With that as the introduction, how would you like to see how we live on orbit and how we conduct some of our business together? Sound like a good plan? All right, let's see if I can get this to be big. All righty. When I got up there, Max and Jeff were already up there, and we formed the Expedition 22 crew. And then after that, after they left, we formed the Expedition 23 crew with the new arrivals. Like any good, really good space story, you have to start with a rocket. And so here's our Soyuz rocket. And this is the morning of December 19th. December 19th in Kazakhstan. Can you imagine the friends and family that are out there watching that at 4 o'clock in the morning? They were frozen by the time they came back. We had a very international crew. Soichi is a Japanese astronaut. Oleg Kotov was our Soyuz and later our station commander, Russian commander. And of course me. And this was a press conference. We had lots of press conferences, and they're asking me, what am I going to miss most? And I said, bubbly water. If you think about it, you can't have bubbles on orbit because they don't know where to go. There's a tradition that on the morning of your launch, you sign your door, and Soichi signs his door here, and then he does something bizarre. He draws his flag. So I sign my door, and I'm going, oh my gosh, do I have to draw my flag? No, we're not going to do that. So we walk out to the commission in our highly tailored Sokol suits, and we report to the commission and say, we're ready to get off the planet. This is the morning of December 21st. We're standing on the launch pad here, and Oleg is ready to go. He's going to go, okay, guys, let's go, up, and go. And like good crewmates, we go, okay, we will, but we're going to wait a little bit more. December 21st, shortly after midnight, and now you get to see what the families were seeing when we take off. You get to see the snow and rain. You put three grown men in your bathtub. That's how much room we have in this Soyuz capsule. And so it's time for the candles to be lit. And if the lights are low enough in the house, you can see that it's raining and snowing and sleeting, and we still go anyway. I asked the family what they remembered most of their trip to Russia and Kazakhstan, and they said first the launch, and then second, oh, it was freezing. A very, very smooth ride, liquid engines, and a very smooth acceleration. It takes us about 2.5 days to catch up to space, a little bit over 2 days, to catch up to space station and get close enough for things to get seriously interesting. And Max and Jeff are already on board, and they're taking the video and the still photography of our approach. And the Soyuz itself has a primary radar system, a backup radar system, and of course a manual override in case everything goes poorly. And as it turns out, we were very fortunate. Our primary radar system worked like advertised and as it was supposed to, so all we had to do was monitor the approach. And so what you're seeing now is what the actual view is that the commander gets, and he gets all the telemetry along the sides of the video that you have there. And this is real-time docking speed. We want to be very careful when we bring these two multi-ton vehicles together, and so we approach very carefully. So this is December 23rd, and we're arriving, and Max is going to open up the hatch, and since it's December 23rd, we have to come prepared for Christmas. So that's Oleg coming up. And after him is Santa Soichi. And he was very popular because in that bag was the fresh food for Jeff and Max. And after Soichi comes up, then comes Santa's happy elf. Very shortly, like within minutes after arriving, we go back to the Russian segment and we have a press conference with the control center in Moscow. One of the nice things about this is we get to talk to the families who went to the control center in Moscow to see the rendezvous and docking. Shortly after this press conference, we do another one, and here's Max showing what it's like to be in microgravity. I think we should all go to work like this. Alrighty. Almost every place we go, we get asked questions, are there space aliens? You can see the shadows moving around on this one. As it truly is, Oleg and Max are outside doing a spacewalk, and they are preparing the space station for the addition of the last Russian module, which will happen later on in our increment. And so they're making the connections, the hosing connections, the wiring connections, and also putting some experiments on the outside. Here we're in the Russian segment, and Max is watching the incoming delivery vehicle called the Progress, and he can take over manually if things are not going quite right. This Progress was the first of two we received, and this one behaved okay. The second one didn't behave very well at all.
While you're dancing, we're flying.
This is actually a quick an introduction. There was a show called Dancing with the Stars, and Buzz Aldrin competed on the dancing show. And so we were making a joke and saying Buzz Aldrin was the original moonwalker, but could he do this maneuver? And then I did the flip. Every day we fight the schedule in order to be able to get all the science, get all the activities done. And one of the biggest things we do every day is we move logistics. We move bags around to get access to racks. We move bags around so in order to do the science in front of the racks. And occasionally, after you're moving things around, you lose your foothold and you just kind of rotate around. So I just kept working on what I was doing. I wasn't drifting left or right. I just kept rotating around. Much science. One of the experiments was going on up there was growing wheat and lettuce. And this is a daily experiment that we photographed back in the Russian segment. Max loved his little garden. Here comes Suichi practicing his microgravity swimming, which is important because shortly after that we did synchronized swimming. This was all in preparation for another public relations interview. You put two helicopter pilots together, and what do you get? Saturday morning science, we were talking to schools, and we were talking about conservation of angular momentum. And so this was the easy way to demonstrate the ice skater problem and how you conserve your angular momentum. Of course, there comes a time when the older crew has to depart, and so Max and Jeff are about to leave, and the change of command occurs. And anytime you have hatch openings or hatch closers, you have to do the traditional hugs and kisses. But it wasn't until I saw this video that I finally understood why I found my camera in the next module. So Max is going to close his hatch on the Soyuz side, and Oleg's going to help him. And so that we don't have a big hole in the space station when the Soyuz leaves, we have to close our station hatch. And at this point, we are 3 guys on space station for about 10 days, all by ourselves, awaiting the next crew to arrive. And that's when we get to do some fun things, like find the fresh food that we hid from Jeff and Max. And we get to do some videos and some other fun things, like how to make breakfast burritos or tacos in the morning. And you have to use bread that's not crumbly, so a tortilla. And the other secret is you have to put the sauce down first to act as a glue, to hold everything together. Oleg said to me, go cut Suichi's hair. Oleg said to Suichi, go cut TJ's hair. And then he looked at the both of us and asked me to cut his hair, because he didn't like how Suichi cut my hair. But of course you have to do certain things special on orbit, like have that vacuum hose attached to the clippers so that you don't lose all the hair all over the place. This is the traditional water bubble, and you get to see the lens effect. Here I'm trying to get some bubbles out of water so we don't damage pumps. And shortly, the next crew arrives, and there's Sasha, Misha, and Tracy. And one of the neat things about new people on station is they don't have their space legs yet. They don't have body control, so they knock things off the wall, and you can see Oleg putting something back on the wall again. It's just the way things are. People need to grow into understanding how to move well in microgravity. And so, again, as you see with the hatch opening, you have the traditional hugs and kisses. While I was up there, we got visited by 3 shuttles. This is the second of the 3 shuttles. And what we are doing here is taking pictures of the shuttle's tiles. The shuttle is doing what's called an RPM, an R-bar pitch maneuver, and it's pirouetting. And as it does that, we take a highly choreographed scheme of photos of the tiles so that we can send these photographs down to the ground and have the ground analyze the the tiles themselves to see if the shuttle is safe to return back to ground. And this is the perspective from the shuttle looking at station. And this is a very special occasion, specifically for Japan. On the station side, we had Soichi Noguchi, a Japanese astronaut. On the arriving shuttle, we have Naoko, and she is the second Japanese astronaut. And so this is the first time that Japan has ever had two astronauts in orbit together, and of course that was a big celebration for them. And once we get all of the equipment out of the hatchways and people cross the hatches, you have to go do hugs and kisses. And the nice thing about zero gravity is that you can do hugs and kisses in any orientation. And as I mentioned before, that every day is a race on the schedule to get to do the science and the utilization. And most of the time we're doing logistics to make that happen. And as it turns out, if you paid attention the last time I had a bag, this is the same serial number bag that I was using last time. Most of the day is trying to make it better and make it more achievable to do the science. This rack weighs about 1,800 pounds. Naoko, who is moving it, weighs about 90 pounds. And so as you can see, if you're being very careful, you can move much mass pretty easily. We'll speed up the video here so we can see Naoko wave real fast. Okay. And they go ahead and put this rack in its bay. This is the Window Observational Research Facility that allows remote people on the Earth, like school kids, to be able to point and shoot cameras at the Earth and take pictures of Earth observational sites. Another major milestone for us and for Japan was the assembly and the checkout of this device called the small fine arm. The small fine arm goes on the end of the Japanese robotic arm, and it has the ability to be very precise in its movement. And you can see in a later image 3 little fingers that are moving where it can actually grab like a bolt, for instance. And so Soichi and I were working on making sure all the joints moved and behaved the way they were supposed to. It was very successful and pretty exciting for Japan. Here Soichi is working with the Melfi Freezer. It's the minus 80 degrees Celsius freezer where we put in largely biological samples that we want to preserve for a duration. In this case, we're preserving these biological samples until the shuttle came up, and the shuttle's now here. And now we take out these very frozen samples and we put them into a thermos, and the shuttle takes them down to Earth where the samples are then analyzed. One of the cool things, I didn't mean that as a pun. One of the really neat things about Melfi, and that's kind of fun on orbit, is what we call the Poof Maneuver. And you'll see the Poof Maneuver here as soon as he closes up that bin, I think. Yep, here it comes. Here comes the Poof Maneuver. On Fridays, we would have a conference with the ground, and I got a tradition going for a while that we would all wear red shirts on Fridays, and the ground started wearing red shirts on Fridays. And so we would have these little conferences to talk about the past week, what's coming up, and anything that we happen to notice in terms of operations. I donated several of my weekends to get several rack facilities together and assembled so that the ground can do the remote experiments. This rack was not operational when I got there, but I was able to help get it together, and it's a rack designed to analyze and do experiments on the unique behavior of fluids in microgravity. This is in the Japanese module now, and this is another gas phase rack that we put together and got operational. And while the shuttle was up there, they had an off day, and so they were able to play baseball. And Clay hits a home run, and now he's going to run around the bases. This soccer ball was actually flown for the World Cup, and it actually made it back in time for the World Cup. And Soichi's going to scream and holler because he scored. Soichi and Naoko were gracious, and they hosted a sushi dinner for both crews. This is very special because sushi has to be very fresh, and so now we get to have fresh food for dinner, which is a nice treat for the crew. Exercise, we exercise about 2.5 hours a day, and Oleg is here lifting weights in a weightless environment. Back in the Russian segment, we often shared lunches back in the Russian half of the station. This is the third of the 3 shuttles that came up and visited us, and now you're seeing it going through its RPM maneuver. and they're bringing up the module that will be attached on the space station on the Russian side. This is real-time speed. This is how slowly we come together, the two vehicles. We open up the hatches, and what do you have to do? Hugs and kisses, right? Hugs and kisses. Now, what you're about to see is Garrett. Garrett stands about this big, so I was able to put him in a module where he couldn't touch the ceiling, floor, or walls, and just left him there. Okay, the shuttle's main mission was to deliver Mimadim. This is the Russian module that we were talking about before, that Max and Oleg did the EVA for the spacewalk for. And they successfully docked it. Talk about international cooperation. Here is Soichi, the Japanese astronaut, working in the European module, and he's out changing samples for the experiment to be rerun again from the ground. I had the fortune of working with some spruce fir trees, and when I pulled these trees out, the air flows back through those hatches, back towards the Russian segment. And within about 2 or 3 minutes, the Russians came down and said, "What smelled so good?" We have to do weekly cleaning because everything gets into the filters. And we were very fortunate when we were up there. We were able to receive and install what's called cupola, this 7-window to the world that allows us to take some great photography. But more importantly, we were up there for April 1st. We had to pull an April Fool's joke on the ground, and so we had this picture taken. These pictures that you are seeing are undoctored, unretouched. These are the views that we actually see out the windows, and we wanted to share with you some of the wonder that we just astound us, that humble us so much. Here's Crete and Greece. Central Asia, or the Stans. I thought this was a really wonderful color combination here. You can take people into the cupola, have their eyes closed. This is Cuba, Florida, and Bahamas, one of the most beautiful and most photographed areas of the world. Bring somebody into the cupola, open up the windows, have them open their eyes, and you can watch them cry. It is so beautiful to see the Earth. A real live, real-time moon set from our perspective. This is Japan at night, and I don't know if you can see with the lights in the house, but I left this in because you can see the pixel damage of the camera. And this is all because of the radiation hits. This was an older camera that had been left up on orbit for a while to test that. Here is Washington, Baltimore, and Manhattan. This is Odessa. I saw this and I just had to take this picture. Took this picture out the Russian bedroom window, and the aurora went dancing underneath us as we flew over. A sunset with the wonderful vista in extreme colors. You get to see some vistas that are just breathtaking. I left this video clip in to show you how big the bedroom is. Tracy's going to come around the corner. She's going to do a hop, skip, and a jump. And then she's going to go into her sleep station, and you get to see basically how big it is. Notice she's holding onto the handrail, and she's fully inside her sleep station. So it's not a very big room at all for a bedroom. Okay, wave to Suichi. There he goes. Okay, like many things, they have to come to an end, and so we're going to take a tour from the front end of the station in the U.S. lab and go head back to our Soyuz for departure. And so we go through Node 1, and you get to see, as we go up this ramp, part of the areas that we try to store things that we use on a daily basis. And this is where we keep our clothes and our shorts and all that kind of stuff. And now we go through the hatchways and into the FGB. And one of the things that I would point out about the FGB is that it's open stowage. We don't have a whole lot of good places to stow things, so sometimes we have to use aisles like this in order to stow things and get access. So we can perform the experiments we need to be doing. That's a lot of where the stowage is. We go back towards the command module here and the service module, and Oleg is getting ready for us to depart. And in the very back here, you get to see Sasha and Misha. And we're going to keep going to the back into our Soyuz. And we're getting ready, we're saying goodbye. And it's about 4 hours, almost to the nose, 4 hours from the time we undock to the time we actually land in the Rescue Forces open-air hatch. Speaking of the Rescue Forces, this is the first time in history they've gotten to the point where we were going to land, set up a video camera in order to capture this. That was the soft landing thrusters firing, and what you're about to see is Bill Ingalls took a picture. He's been trying for 15 years to get this shot. He actually captures the soft landing thrusters firing before we impact with the ground. As far as the term soft landing thrusters, it's a misnomer. And so the rescue forces pull us out, and we get to do the reacclimation back to Earth and gravity. And one of the most wonderful sensations is when the hatch opens up, you get to smell the aroma of the Kazakhstan grassy area, and it's just wonderful to have clean air. The Russians made this very famous poster a bit of a joke, and they put our faces into it. And then the last thing I would like to leave you guys with is this is digital, high-definition video that a space shuttle takes as it goes around the space station. And so this was the third shuttle took this video of us. This is not computer animation. And I just thought it was a wonderful visual portrayal of our home above our home that has no borders. We worked as an international crew together on many scientific experiments very successfully, and I will tell you without blinking an eye, it was the height of my professional career to participate shoulder to shoulder with my Russian compadres and my Japanese compadres. It was just delightful. With that being said, I hope you enjoyed that little tour, and I think we'll be available for questions afterwards.